So, good morning. It's nice to see that many. I hope you had a good party, and obviously it was not too long, and you made it this morning. So I will talk about how to work with middleware and how to connect it to user interfaces with the three technologies Qt, QML, and HTML5. So before we start, a very short introduction to Basyskom. I'm the founder of Basyskom. We are offering embedded engineering services from the kernel, graphics, optimization, integration, up to the user interfaces, and work a lot with Qt here, but also with WebKit and HTML5 recently. And we're located in Germany. Okay, so why caring about middleware at all? Well, if you create an embedded device and want to add a human-machine interface to it, nowadays the demand is growing a lot. You need more features. Users want touch interfaces or even multi-touch. They want it to easily use. They demand more features connected with a cloud maybe even. And so the whole development has to be faster and more flexible to adapt to those changing requirements. So this also affects the architecture of the software, of course, because it needs to be more time efficient to create it so that you can add features much faster than in the old days when we were all still coding each single pixel. So what are the requirements exactly? Of course, it's reduced time to market. We need to be faster with new user interfaces, with new features. But then we need more flexibility, like different OSs, even different Linux versions, different devices, formats, and different user interfaces depending on the product variant maybe. So it's a diversification here in the offering. And this means we need to improve the quality of the service from the architecture point of view. We need more usability in the user interfaces and adapt it, but also stability, security, and scalability, meaning this amount of features, amount of functionality in the software. So we need a sustainable software architecture here. So this means when you have the whole software stack, from the hardware, OS, middleware, including the backends here. So when I say middleware, I mean backend has the functionality. It could even be a server, whatever, but you need always a middleware with an API that you can access from the user interface. Then you have frameworks, standard components most of the time, like the libraries coming with a operation system that you're just using. You probably create HMI components and then the actual custom HMI. So when we talk about a product with features, those features usually happen in the middleware layer, the backend, where you add your features, and then also in the HMI layer, of course, with the custom HMI. And all the other components, you try usually to reuse things, because otherwise you lose time in implementing them, ensuring quality, and all these things. So the middleware is in a way here the glue with its API that you access from the user interface, and this also determines your architecture. So when we look how we implement the middleware and the requirements here, for the middleware, especially in the embedded, and that's what we are talking about, it's most of the time C or C++. Sometimes you use an IPC mechanism or even a remote protocol, but usually you have a library locally with an API that you can access. So this is kind of the starting point. So when you want to access the middleware from the user interface, you want to have little coding overhead, of course. So when you change things, you don't have to maintain a lot of code. You don't have to write a lot of code. You want this access to the middleware to be fast so that you don't get latencies in the software later on when you run it. You want the setup to be robust, just to mention type safety here, or other things, so that you can debug the whole setup, that you can find errors, bugs here, and then with this setup, it's way easier to reuse and maintain it the long term. So if you look into a typical embedded Linux system, we have, of course, the embedded Linux core. Then we have Qt, QML, and WebKit. I mean, here we are at a Qt conference, so this is the typical setup. And we have the custom middleware with backend maybe that we want to access. Okay, so how can we do the HMI? We see 4 alternatives here, which is of course plain Qt, QML, but then also we see in the market that many also evaluate HTML5, mainly because you can easily port the software, the HTML5 user interface to standard devices like tablets, mobile phones, and so on. So that's why it's an alternative, and that's why I decided to add it to our selection. We're looking into 2 variants here. First is just plain HTML5, standard HTML5, how to access the middleware here. But then also we can add APIs to the local runtime, and that's the last example we are looking into. Okay, and then the question is, we're now looking into how to connect these things, and I've brought 2 of our engineers for this because it's 2 very different topics. I brought Bertolt Grewert for Qt and QML, and Sumedya Vidyama will look into HTML5. Okay, so I hand over to Bertolt now.
Is it okay? So, okay. Yeah, good morning to everyone. To introduce myself, I'm Bertolt Grewert. I'm a consulting software engineer at Basyskom. Okay, thanks. And I want to tell you something about the Qt connection to the middleware. So let's start straight or go on to Qt. Qt is that what you already know. It's a C++ development framework. You can just use libraries, link against the libraries, and use your middleware libraries in C++. The connection to the middleware is done through the function calls. You can use signal and slots, of course. You can use the complete QtMiddle object system. If you like, you can also implement a daemon and connect to the daemon via IPC, for example, dbus. So let's go straight to the code let's make the things a bit more interesting. What you can do is write a small wrapper library around your middleware that inherits from QObject, so that you get all the advantages from the QtMiddle object system, so that you can use the signal and slots. There you can trigger actions, set values. There you are going to get notified about changes. that is the way to abstract the backend. We have a small, very, very small and yeah, basic snippet called middleware object with a activate method or an activate slot that you can call from your GUI. The graphical user interface is just the main method here with a Q application, a push button. You can click on the push button, call or connect the signal from the push button, the clicked signal to the activate slot inside your middleware object, and there you have the connection. So it's basic is that what you most probably already know, and it's very easy to access the middleware. So what do we have? We have high quality and a stable and well-known framework that you can just use. But what are the disadvantages of this method? Um, for the first one, touch screen interfaces are very complicated to implement with Qt widgets and with the basic functionality Qt gives you. It's more suited for yeah, classic applications with a QMain window, menu, toolbar, and so on. On the pro side, you have yeah, you have that what we call one-stop shop. It's all C++, and you can just use one language. You can link dynamically against your library and your framework, and you get the methods. You can just use them, and this is really easy. But on the other side, it's yeah, old, and you get your old GUIs. On the yeah, con side, as I said, it's not touch friendly. You won't go to use it for touch interfaces. GUIs have or if you write a GUI, you are going a more decorative way. If you write a GUI, it's not something that needs an imperative mindset or imperative paradigm. And yes, I think that are the main disadvantages. So let's go straight to QML, and so that I can explain you the middleware connection from QML. QML is in some parts the opposite. It's very design centric. It's simple and simple to learn. It's written that guys who don't have much knowledge about programming can just sit in front of their PCs and Macs and hack the first application. So it's very easy to get started. Animations come with nearly no cost. They are implemented inside QML. It's very easy to get animations running. It's part of the language. You get GPU acceleration for free because next generation QtQuick 2.0 has a scene graph, and the scene graph is hardware accelerated, so you get the GPU acceleration at no cost. Yes, and the next pro is that QML is part of Qt, and so you get all the advantages you have in Qt also. Also, you have all the advantages in Qt also in QML. So it's very easy to extend QML with Qt and on the Qt side with C++ code. So let's go to the source code again. We have a small example. Let's say we have a manufacturing system with some entities abstracted in a machine class. And we want to export our machine entity to QML. So we just write a class machine in C++. We use a QtMiddle object system again to be able to later access all the middleware functions from QML. So and how can we do this? We can do this with Q properties to set values, to export values to the middleware, to read values from the middleware in QML. We can use Qinvocables to trigger actions in the middleware from QML. It's done with Q properties. You just have for example the rotational speed. You can write a Q property list, set it to rotational speed, set the getter and setters, set the signal with notify, and so yeah, let's see how we set the rotational speed. Whenever the rotational speed changes, we use the setter in C++, set the rotational speed there, and then we emit a signal when it changes, so that the QMeter object system sees when it changes and can notify the properties. And that means that we can get the property binding. So we have the advantages from QML when we use the QMeter object system. And after we have written our plugin and after we have exported our getters and setters and our methods, we write we can go and make it a module. So we write a plugin that we can import in QML, and we can do this with a Qt plugin system. When we write the Qt plugin system, we need the method register types. There we register all the abstractions we have written before. We register them to the QtMeter object system so that we can just use them later. We need to write a small QML here with the name of the module and the plugin, and then we can finally write our QML code. It's a small code with a rectangle, a small button, and here we have finally the machine where we can set the rotational speed. We can set the rotational speed and get the state from the machine through property binding, and there we can use our formally described middleware. On the top you see the import statement. We have written a plugin, so we can use the import statement to really import the plugin, and then we get all the classes. So let's go to a maybe more complicated example, or not more complicated, but we cannot just use integers and bools and all the basic types, but we can fortunately access all the data structures Qt delivers, for example, QLists, QStringLists, QAbstractItem model. So if you have written a model, and if you have a model inside your middleware, you can again just use it, export it to QML, and just exit it there. For example, we have some list here. Have a Q property again, make it accessible, export it with Q property. set again a signal whenever my underlying model changes, and after we have done it, after we have exported it in QML inside the plugin, we can use it in QML and just put it, for example, in the list view so that we can see my model inside the list and yeah, have it there. Another way to export models is to use context properties. Context properties means that you don't abstract your data model inside an entity, but you put it inside your global namespace. So if you have a small wrapper around your QML application that just opens a quick view, takes the main QML and displays the main QML, you can get access to the QML engine and set a context property there, and then it gets global and you can use the global model, the global parameter, and use it in your whole application. That's another way. It's the other way around. Yeah. The evaluation QML. What does it mean? What are the pros and the cons if you want to use it? The pros in QML, well, one of the pros, of course, is you have access to the QtMiddle object system, which is a good thing because you can reuse your well-known technology. You get the complete Qt system. You can access all the stuff you know from Qt network, as SQL stuff and so on. The integration is very easy with signal and slots over the QtMiddle object system. And the next advantage, if you properly design your middleware access, your wrap around the middleware or your whole middleware, you can maybe reuse it for more than one applications. For example, if you have a system which has to be accessed via a tablet and has to be accessed via a desktop system, you can write one middleware and two graphical user interfaces, one in QML for the fancy side and one, for example, in Qt widgets for the classic side on the desktop. The cons are, for the first time, you have a more complex technology stack, of course. You are using not one language, but three. You have C++, you have QML, maybe you have a lot of JavaScript. So the whole stack gets maybe a bit complicated. And the next con is that the requirements are a bit higher. In 2012, it's maybe not such a problem, but you need, if you want to use Qt Quick 2.0, you need something that is hardware accelerated. So you need a GPU with OpenGL ES 2.0 support. And yeah, that's from my side, and I would like to.
It seems to me like it's something you're just putting cons out there because you have to, because more languages, just something it's not that much of a problem if you also get rid of widgets, for instance. You get rid of one type of technology and replace it with another. Go from widgets to QML. But you can also GL. So those are
Yeah, there are in the internet there are a lot of discussions from guys who don't like to use JavaScript, for example. You are forced to use some other languages. You don't have to see it as a disadvantage, of course. But you get from one language, C++, to more languages. And if you use HTML5, you even have more languages. And so that's maybe the red thread to inside this slides. Yeah. So first we have C++, then we have QML, JavaScript, C++, and with HTML5 we have even more languages. We have HTML, CSS, and JavaScript, and C++, and so it gets bigger and bigger, and you have to.
If that's a problem for you, but it's a lot of sort of like the weak problems, because most people have OpenGL and doesn't have a problem with multiple languages. It could be some.
Okay.
Hello, my name is Sumira Vidyadama. I'm a system engineer at Basyskom, and I will present to you how to connect your HTML5 user human-machine interface to the same middleware that you have maybe written already, or you want to write on a Qt stack, on an embedded Qt stack. So about HTML5, as we've heard yesterday in the keynote, QtWebKit is an essential part of Qt 5. So if you have a Qt port on some platform, you already have something where you could write HTML5 apps and run them. But yeah, if you really want to. The development model is, of course, HTML, CSS, and JavaScript. Everybody knows that. And you have a very large user base. There are lots of web designers who could possibly use this technology to implement a human-machine interface for you. And now you want to connect it to your libraries or your backends. How could you do that? Another point is modern UI features like multi-touch support and accelerated animations are also in the modern HTML5 engines, which is in the QtWebKit that is in Qt 5. So you'd get CSS3 accelerated transforms and multi-touch areas and all these things. One thing I think why people want to have the option to have HTML5 HMI is because it's theoretically very portable. You could take the same HMI and put it on a tablet or a smartphone or something like that, and would not need that much more develop. It wouldn't have that much more development overhead to get it to run there. Huh? Yeah, I will. We'll come to that. Okay, if you have plain HTML5, how could you access your middleware? The most well-known access method is XML HTTP requests, or AJAX. So you just get, post, put, and delete via HTTP. This has worked well for a long time, but it's a very high-level access method. Doesn't really support persistent connections, and it has high latencies if improperly used. So another technology has been introduced, which is WebSockets. They're fairly new and not all that well supported on the server side, I think. I think most clients support them nowadays, and they are. There's even some people are trying to get them into QML, so you could use WebSockets in QML. They are basically TCP sockets for web applications or QML applications. So they might be an interesting option for the future, but right now I don't know if the technology is ready to be used. This could already be used with your existing middleware if you wrap it in an HTTP server or something that is WebSocket capable. Then you could just use plain HTML5 to talk to your WebSocket or HTTP enabled middleware, but you would of course have to write that wrapper, and it's an additional layer of abstraction, and could on embedded systems especially could introduce latencies or issues that you don't necessarily want to introduce. This is a very simple example for an XML HTTP request. This is how you would do it. Nowadays, nobody uses them in this form, but they use some library like jQuery or Dojo to abstract them even further and put another layer of JavaScript on top to abstract out issues with different engines and different behavior on different platforms. Like Internet Explorer doesn't always work in the same way as WebKit does, so you have to be very careful in that ecosystem. And people who use these technologies, HTML5, they're very much aware of those issues. That's why they use some more abstraction on top of the standard just to be sure that things work the way they expect them to work. Okay, so but if we're not content with that, if we say, okay, this is too slow for me, or I really want to use my the middleware abstraction I've already written in Qt, then we can also do this. We can use QtWebKit, which we have if we have a Qt5 stack, and connect the Qt functionality into the runtime. It works a little bit like in the QML example before. I will show you an example in a few slides. It works like this, that you define a middleware object with the QtMiddle object system and exposes into the JavaScript context of the web page you're showing, and then you can directly interact with the underlying implementation. And you can also go the other way around. So Qt could run JavaScript in the web pages context if you really want to. And you can even connect signals and slots from JavaScript. I don't think I have an example for that, but if you're interested, you can come later and I can show you here. There's something working here. Okay, this is the simple example from before. We're just activating a function in from JavaScript directly in Qt. You would have the middleware C++ library or the Qt library, and you would write a Qt app with a QWeb view and load this very small HTML file where you see there's a button with a on-click handler for middleware.activate. Now, middleware is a window level object. You would have to create that, and we're going to inject that object from the Qt side into the runtime. And this is, of course, a fragment only. The library has been shown before. Activate is a slot or a Q invocable, whichever one suits you best. You have a middleware object. You wouldn't actually do it like this. You'd call the add to JavaScript window object function in a signal handler that tells you the page is ready to be used. But with this small example, it works, but don't do it like this. If you want to know how to really do it, look at my larger example. This is just for demonstration purposes, and it works like this. And if you do this, the middleware object, which has the activate slot, is exposed into the runtime, and this example will run. You'll get a Qt debug output activated and activate your machine button or something like that. This is a very trivial example, of course. It's not that interesting, but it shows how easy it can be done to inject Qt functionality into your runtime. Okay, a little more complex example. It's just a QStringlist model. I imagine we have something that has a QStringlist model, and I want to expose that into my JavaScript UI. Now, I really don't want to handle all that data in the JavaScript by myself, so I'm using a helper library. It's Knockout.js. It's kind of like data bindings for HTML tags. So you can, in a declarative way, say you have a data model, like it's a JavaScript object, and you say, from this object, I want the properties in bound to this tag, so they will show up as a value or a text in that tag later on. Knockout will take care of that. If you want to look at it, I like it very much for this kind of stuff. If you have very large data models, maybe you need to look at other stuff. The functionality I want to implement is that changes on the web page get immediately propagated to the C++ backend. So I have an immediate response. I fill in a new line in I'll have a list of text entries, and if I add a new entry, it's immediately represented in the QStringlist model in the backend. That's the aim I'm going for here. This is a small example because I couldn't think of anything better. If you want to add something to a list of system properties like Wi-Fi networks that you want to access which are hidden or something like that, you could use something like that, and it could introduce it into your system backend. Okay. That would run in your My Pages Ready handler. This adds three objects into the namespace. Qt is something. There's quit. You can call quit from the application. Console is for logging, and the middleware is the interesting part. It's implemented in the same class, but it doesn't matter. Here you can expose the same class as different names too. And the middleware supports 2 slots. One is model, which returns the string list. I cannot immediately return the QString list model. That doesn't work, but the string list works. It will show up in the JavaScript context as a string array, a JavaScript string array. So I can directly call this slot and use a JavaScript string array in my code, in my JavaScript code. And the other one is update. This is the part where the JavaScript code supplies a JavaScript array, which will be automatically translated to a QStringlist array, and I set the string list on the data model. This might not be the best way because it doesn't trigger data changed signals, but it's for demonstration purposes, it works, and you can do it more verbose and more correctly, but this is just to show how it could work. Okay, on the HTML side, I have knockout initialized and I have a data model. It's just a JavaScript object really, and it has a few functions. Reload model is the function that will load the data from the backend. This is now called manually. I'll use the pointer. You can see here's the middleware object. I have some safeguards here, so I can load this page in a standard browser, but it will not do anything. If I don't do this, it will show me JavaScript errors because we have extended the runtime and we don't have the objects present in the standard runtime. This is another slot in the middleware. It tells it to actually reload. It's a middleware, so it reloads the model from the backend, which is in this case a file. And self.entries is the entries list. It's a knockout array. It's a little more complicated than a JavaScript array, but basically it has the same functions. I just initialize the entries with a plain JavaScript string array, and knockout works like this. It will populate my forms with the data, and I can see all the entries I have in my backend model. Another interesting thing, I want to immediately, now I want to have knockout immediately tell my backend if data changes. This is an interesting thing that knockout has, is computed functions. It's kind of like property bindings for QML. When I have a computed function in knockout, it evaluates what's in it, and there's a dependency on self.entries. So whenever self.entries is changed, this method is called. Whenever I add something in my forms, knockout will automatically do this, no matter where I put the binding. I don't have to manually trigger these things. The 2JS is to get rid of the knockout extra, so it converts it into a plain JavaScript string array, and it calls middleware update with a plain array, and it works like this. The new string list is set on the model in the backend, and it works. You can also connect signals from the JavaScript side. If you have a signal in the middleware, let's call it updated, then you could call middleware.updated.connect and put a JavaScript functions as a parameter, and it would be called whenever the signal is triggered. This works for all signals. I don't have it in the slides. I have it in a demo code. So if you want to look at it, you can come to me afterwards. You could of course this is the data change signals. You could of course proxy the data changed signal through your middleware stub, so you immediately get informed when updates to your model have arrived, and you can reload the model then. So evaluation of HTML5 on QtWebKit. So it is possible to write interesting HMI in HTML5 if you have the designers and if you have the skill set. We've said that big technology stack is not necessarily a bad thing, because you can pretty clearly separate what the interface designers do and what the backend designers do. You just have to be clear about the API, and then you can just give it to 2 departments. You can even give them JavaScript stubs, which just return normal JavaScript objects or string lists or whatever. And they can work with that on example data, and you just adhere to that convention, and you have two departments which can develop HMI and backend, and you're set. So the pro is, if you have an HTML5 front end, it will probably run out of the box. There could always be issues, but there's a pretty high chance that if you already have something, it will run. And the other way around, if you develop something for QtWebKit, you could probably fairly easily port it to a standard platform like a tablet or a mobile phone. And another big pro is if you really need faster response times or very low latencies or something like that, if you say, I need access from my JavaScript code immediately into my backend, that's possible. You just need to modify the runtime. And of course, we have a con point down here. If you do that, you're not standards compliant anymore. Then you need to work around that if you want to port your application to another platform. Another con, because we had that before, it's maybe con is too hard of a word. Maybe it's issues or things to think about. It's you have a very deep technology stack. I mean, but if you have the people for all those technologies, I don't think it matters. And another thing that's maybe more of an issue is that complex data models are not automatically translated into JavaScript objects. So you might have to take care how you model your data. I think you can use qvariant constructs, and they will be translated into JSON, and the string lists work, but depending on how complex your data model gets, you might have to add some further abstractions for the HTML5 application side. Yeah, for the conclusion, I give it back.
So I would like to summarize what we heard in these two parts. Well, first, Qt is very straightforward. That's what we heard. It's only the issue that touch UIs is not really the way to do with Qt. That's where you use QML. And regarding QML, you can create HMIs very straightforward. Use the middleware with only very little overhead, and use the Qt mechanisms to do it. I mean, QML was made for that, and you feel that, and even if you mention some cons, they are really weak here. So it's usually, if you start an embedded project and want to create a product, this is really the best technology there, and just go for it. However, there are sometimes reasons to think about constraints, and that this is maybe not something you want to do, and that's why it is interesting to look into HTML5. Yeah, we heard there's two ways to use it. First, the normal XML HTTP request with a small HTTP server, very standard compliant and portable. But there's also the alternative to extend your runtime and to use the middleware here. But you get a large stack. It's not that straightforward. You saw that only the example was way larger, more code to handle. And this is, of course, some overhead here. So I would like to mention, though, a quite big advantage of Qt here, because if you have Qt on your system, you have all of those three technologies, and this is just great. I don't know another system which has that, because you can use Qt for maybe a complex list you have in your user interface where QML is maybe too slow or something. You can speed it up using plain Qt. You have QML for the designed user interface to quickly create the user interface. But you could also embed just HTML5 apps being downloaded from somewhere, being updated. You have it all in your system. Well, and the last thing I would like to mention is that I can only emphasize in all our projects we see that it's a very good thing to clearly separate middleware backends from the user interface to be faster and to really go for this architecture. Okay, thank you.